This video is just an experiment to see how Morse code audio tones would sound over a low-bit OPUS codec VoIP app called Seren. We have it as low as will go, which is about 6K. So we have 6,000 bits. Normally you need about 48K or above for the Morse code tone to sound pretty good over the OPUS codec. We found that 96K is really good. You don't notice hardly any edge noise at all, and it's a very pure tone. However, at 6K, it's quite a different story. You have a very harsh tone. It doesn't sound very good. However, the second part of the experiment is to see if we could regenerate it successfully, even though it's a very poor beginning tone. Original tone is fairly poor. Can it be salvaged using CW regeneration, and thus you'd be able to use a very low bandwidth and connect more people on your CW net. Seren, of course, is a full mesh, peer-to-peer, automatically connecting networking app. It runs in the terminal, and you only need to connect to one node, so only one person needs to have a node that's on all the time. And we did a previous video where we have a Raspberry Pi set up as the node. It's always on, and it's really not used itself. You just log into it. So everybody can use that one IP address, that one port forwarding on the router that the Raspberry Pi is on, and you can have a very a good experience at QSOing over the internet using Morse code audio tones in a CW net. It's full QSK, it's full duplex, so you can break in anytime. Anybody can break in, everybody else will hear it. So let's listen to the original tone so you know what we're starting with, and then we'll listen to the regenerated tone to see how well of a job it does. As you can see on the scope here, the green is the original waveform. It's kind of glitchy and it's got gaps and breaks in the audio waveform. However, the regeneration, as you can see, can take the original wave and make a pretty much near perfect wave out of it, even with the nice raised cosine edging on the rise and fall time as you see here. So let's take a listen. Let me show you the setup here, how we're doing it. We have FL Digi that sends CW tone at 1K, 1 kilohertz to the Seren input. That goes into the other room through the Raspberry Pi Seren and out its own analog speaker jack. I have an audio cable from that speaker jack coming back to the laptop here using a Behringer USB sound card, a UCA 222. So that's going to a fader, so we can show you the original, and then it also is connecting to the Regeneration app Reaper here. And when we turn it all the way to the right, that fader, then you'll hear what that sounds like. So the original tone will be next. You might want to turn your volume down just a little bit. The waveform's a little bit harsh. So we'll have FL Digi send a bit of a text file. And let's copy it again. And hit transmit. And as you can tell, that was very harsh, very unpleasant. You really would not have a good time for a long QSO listening to that tone. So let's regenerate it and see what it sounds like. And that made a big difference. Pretty much I would have to say that's pretty usable. It sounds very pleasant to me, and it represents the original wave very, very precisely. So I say that's a pretty good test experiment result as far as trying to regenerate a very unpleasant waveform. And we're doing that in Reaper, so I'll show you the Reaper setup here. This is what I've been using in some other videos for CW regeneration. So we take the original tone on the input and we run it through these apps. we run it through a filter where we filter that 1K tone, so mostly that's what's getting through to the next app, which is Retune, which just verifies that it's at 1K. So we have Regate zone, low pass and high pass set to about 1K, something like that. And we have these adjustments here. So we open it up 1 millisecond, tack at 0, release at 0. We're holding for 11. This helps stabilize. So you, on FLDigi, we're using -17, and this is just arbitrates, which sounded pretty good. So we're taking 17 milliseconds off of every element. That allows us in Regate to hold it for a certain amount of time, and that prevents glitches and gaps. And so as you see over here on the screen waveform, there's a little gap right here, so that you would get a pop or a click there. So that helps take that out. And it does a very good job. And then the next one is a synthesizer. So when you set Regate, see this threshold right here? You set that to where it's sort of like that at the very peak. So at the very peak of the FLDigi tones, that's where you would want it set, where the green, the top of the green and the top of this little slider match. That gives one of the better results as far as the timing goes. You're trying to match, so if you had a 10 millisecond, let's say 20 millisecond DIT, you want to adjust this to you get a regenerated DIT at about 20 milliseconds. And you can pretty much do that by ear. So if you go too far down, it makes the DITs too long. If you try to take it really high like this, where you just match that line to the top, it's a little unstable, but it makes it just a little bit lighter. And so the reason the Regate can key a synthesizer, a software synthesizer, this is a sine wave synthesizer called Resynth. We have the attack and release at 5 milliseconds, which is the rise and fall time, respectively. So Regate analyzes incoming element. When does it start? When does it stop? By setting that threshold. And then that sends a command to send out a MIDI note instruction to the synthesizer. And the MIDI information just tells the synthesizer when to turn on and when to turn off. You can adjust the volume on Resynth. You can adjust the tuning where you can go up or down. So that's an extra feature too that's really nice. So you could change the pitch that you're hearing just by doing that, and how much volume you wanted, and whether you want the pitch a little higher or a little bit lower. Then we have a final polishing filter to take the 5 millisecond edge noise, which there is a little bit, and you can take that out even more with something like this. This is just optional. You don't have to have this, but it cleans it up a little bit and gives it a little more of a raised cosine shape, as you can see here, instead of it being just perfectly, at a slant without any sine wave curve to it. And that's pretty much the regeneration part. All these are already in Reaper, so you don't have to go out and get any more. So when you download Reaper, you get these to begin with. And Linux now has a native Linux Reaper version, and I'll be some links in the show notes to show you where to get that if you're interested. So I think that's pretty much it. So we're just trying to do an experiment to see if FLDigi sending out a 1K tone to the Seren input at 6K, the lowest bit rate possible, would be able to be regenerated well enough so that it sounds good, even at 6K with some of the waveform missing. And the results, I think, were pretty good at this. Reaper does a really good job with its regeneration mode. Thank you for watching.